welcome to my front yard. So we are going to be starting chapter 6 today. Chapter 6 is all about trig functions. And so this first lesson, we're talking about inverse trig functions and what that entails and how we need to restrict them. So without further ado, let's get to the notes. Okay, so let's first do a little bit of a review of inverse functions in general. So as you remember, either from 122 or from Algebra 2 trig, for inverse functions, we switch x and y. And so if we take a function like y equals sine of x, to find the inverse, we just simply draw our graph. And so this would go up to 1, down to -1. This would be at the point pi over 2, pi, 3 pi over 2, and 2 pi. So we can find the inverse even if it's not a function just by switching x and y. And so then the inverse would look like this, where now our x's go from -1 to 1. And then our graph would look like this, where our y value is now pi over 2, pi, 3 pi over 2, and 2 pi. However, if you remember, in order to be a function, it has to pass the vertical line test. This clearly does not pass the vertical line test because it's going to hit it more than once. So when we're talking about the actual inverse function, we want to be sure that we restrict our domain. So if we're looking at our sine function, so if we extended sine, so this would be negative pi over 2. Because remember, we could get sine continues on. So if we restrict our sine function to just be between negative pi over 2 and pi over 2, then whenever we flip it to get that inverse, it's still going to be a function because it then would pass the vertical line test. So let's just make some notes of this. So for our sine function, so again, this is our graph. If we restrict it between negative pi over 2 and pi over 2, then our inverse is going to be, so again, our y values are between -1 and 1. So those now become our x values. Because we restricted it to be between negative pi over 2 to pi over 2, those are going to be our y values, negative pi over 2, pi over 2. And so then we would take this point at negative pi over 2, 1, sorry, negative pi over 2, -1. And so that would be the point -1, negative pi over 2. Then we have 0, 0, and then 1 pi over 2. So our graph then looks something like this. And so again, that's just switching our x and our y values, and then we can actually type this into our graphing calculator to sort of see this a little bit better. But this would be y equals sine inverse of x. And so again, now, because again, our domain and range switches, so our domain is going to be between -1 and 1, and our range is going to be -π/2 to π/2. So I should have clarified, this is restricting the domain or x values. So cosine's pretty similar, but because the graphs are just ever so slightly different, then the inverse, what we want to restrict it to, is going to be different. So cosine, because remember cosine starts at the amplitude and then goes down. So this being at π/2, pi, 3π/2, 2π, 1, -1. So now if we look, we can actually restrict it between 0 and pi, because if you look, if we just look at what I highlighted in light blue, we don't have any repeats, or it passes the horizontal line test, which means that then whenever we flip it, it would pass the vertical line test. So for our cosine inverse, we're going to restrict the domain to zero to pi. And so then when we graph this, because we're restricting our domain to 0 to pi, that means that that is now going to be our range. And then our domain is going to be the range of cosine, which is -1 to 1. And so then we take our points. So this is the point 0, 1. So then that becomes 1, 0. And then this point at π/2, 0 becomes 0 π/2. And then this point at pi, -1, becomes -1 pi. And so then this inverse looks like this. Okay, so then for tangent, and I kind of ran out of room. Hopefully you guys still have some room. So for tangent, we can actually, these are a little bit easier to see. So our tangent graph, if you guys remember, was when we just graphed one period, we typically graph between -π/2 and π/2. And so this graph, if you look, passes the horizontal line test. And so if it passes the horizontal line test, that means that when you take the inverse of it, it will then pass the vertical line test. So this is y equals tangent x. And then for y equals tangent inverse of x, that graph will be, now our y values are going to be between pi over 2 and negative pi over 2. Our vertical asymptotes are now going to become horizontal asymptotes. And then we would flip our graph so it would look something like this. And so if we go back to tangent, if we restrict our domain to be between negative pi over 2 and pi over 2, then our range, and our range for tangent has always been negative infinity to infinity. So now whenever we switch that to find the inverse, now our domain for tangent inverse is negative infinity to infinity. So we can take tangent inverse of anything, but then our range is going to be between negative pi over 2 and pi over 2. And so this especially pertains to what your calculator gives you, because your values are going to be between negative pi over 2 and pi over 2, or negative 90 and 90 degrees. Okay, so then this really helps us to sort of understand where our restrictions of the domain are going to be. And so again, these are our inverse functions. So this is the opposite of, so our x's and y's are flipped. So the domain for sine inverse is going to be negative 1 to 1. So we can only take sine inverse if it's between negative 1 and 1. And the interval that it's going to give us is going to be between negative pi over 2 and pi over 2. And so this is in quadrant 1, and then it's the negative of quadrant 4. Or one way of thinking about that is it's also the same thing as quadrant 1, but negative. And so then for cosine, again, the domain of cosine inverse is going to be between negative 1 and 1. This time the interval is going to be between 0 and pi. And so that just means that you look at quadrant 1 and quadrant 2. And then for tangent, we can take tangent inverse of anything. So that's negative infinity to infinity. But then the interval that it's going to give us is negative pi over 2 to pi over 2. And so again, that's in quadrant 1 and quadrant, and then negative of quadrant 4. Or again, negative quadrant 1. And so cotangent is kind of similar, but because cotangent has its cosine over sine, the domain is still going to be negative infinity to infinity. But if you think about how we drew our cotangent function, it's the interval in which it's going to give our angles to us is going to be between 0 and pi. And I actually need to make these brackets for tangent and cotangent parentheses, because it can never actually equal these angles, because cotangent of 0 is undefined. So therefore, we can't take cotangent inverse of a value to get 0. And so again, cotangent is going to follow the same as cosine. So this is going to be in quadrant 1 and quadrant 2. And then secant inverse is 1 over cosine. And so our domain is going to be between negative infinity to negative 1, union 1 to infinity. So basically we can't take secant inverse of a number that is between -1 and 1. The interval is going to be similar to cosine, so 0 to pi, but again, not including 0 or pi. So that's quadrant 1 and quadrant 2. And then cosecant inverse has the same domain as secant, so it could be anything between -infinity to -1, and then 1 to infinity. But because secant is 1 over sine, it's going to give us values between -pi/2 and pi/2. So that's quadrant 1, and then the negative of quadrant 4, which is the negative of quadrant 1. And so what I mean by that is if we are in, so quadrant 1, we have our values of pi/6, pi/4, and pi/3. In quadrant 4, on our regular unit circle, this is 11 pi/6, 7 pi/4, and 5 pi/3. Okay, so my iPad overheated, so I'm now inside. So in our fourth quadrant, we have 11 pi/6, 7 pi/4, and 5 pi/3. And so that is what is on our unit circle. However, these are the same angles as it being negative pi/6, negative pi/4, and negative pi/3. So that's what I mean by negative fourth quadrant, which is the same thing as negative quadrant 1. And so anytime that you are wanting to take sine inverse of a number, so if you're taking sine inverse of -1/2, for example, that would be negative pi/4, or sorry, negative pi/6. So we also be looking at our unit circle in that sense, but anytime that it's in quadrant 4, we are going to use these values, not the ones that are on our unit circle. So if you have your unit circle at home, you can then make those marks in your unit circle that 11 pi/6 is the same thing as negative pi/6. 7 pi/4 is the same thing as negative pi/4, and 5 pi/4 is negative pi/3. So that will particularly come in handy when we are talking about these. So if we want sine inverse of 0, I'm going to go to my unit circle and then sine inverse of 0. So I want to know when our y value is 0. So this one might be a little bit confusing because this is just 0. And so for all of these, we want them to be in radians, so they're going to be our radian degrees. So cosine inverse of -1. So then we want to look at our unit circle, see where cosine is -1 in 0 to pi, or in quadrants 1 or 2. And so this would be pi. Now, for this third one, so arctangent is the same thing as tangent inverse. And so I personally prefer this method of writing it, but these mean the same thing. So again, we want to find where on our unit circle tangent is -1. The only difference is because we are doing the inverse function, tangent has to be in quadrants 1 or 4, but the negative. And so if we look, tangent's positive in quadrant 1, so we look in quadrant 4, and that would be 7 pi/4. However, we don't want to write 7 pi/4 because that's not between negative pi over 4 and negative pi over 2 and pi over 2. So instead, this is going to be negative pi over 4. So then for sine inverse of root 2 over 2, the positives are easy because we're always going to be in quadrant 1. No matter what inverse function we're talking about, if we're talking about a positive inverse function, we're in quadrant 1. And so sine inverse of root 2 over 2 is going to be pi over 4. But then sine inverse of negative root 2 over 2, so for sine, we want to look in quadrant 4, but then negative. And so we're looking in quadrant 4, sine would be negative root 2 over 2 at 7 pi over 4, but that is going to be negative pi over 4 because it needs to be between negative pi over 2 and pi over 2. But now for cosine, cosine is in quadrant 1 or 2. And so for cosine, we are going to look at between 0 and pi over 2 for when our x value or cosine is negative root 2 over 2. And so that would be at 3 pi over 4. And so because our interval, we want it to be between 0 and pi over 2, it would still be 3 pi over 4. And again, arc cosine is the same thing as cosine inverse of negative root 3 over 2. And so again, because we're doing cosine, we want it between 0 and pi. So we look at our unit circle, we're going to be in quadrant 2. And then we look at negative root 3 over 2. So that's going to be 5 pi over 6. And then sine inverse of 2. Well, sine, the domain of sine inverse is between negative 1 to 1. And so because 2 is not in that interval, this does not exist. Okay, so those are our functions that we can look at with our unit circle to determine what the angles are. And so again, one thing to sort of reiterate is that anytime that we're taking sine inverse, cosine inverse, tangent inverse, secant inverse, cosecant, we are always looking for the angle that gives us that value. And so there are times where you will plug those into your calculator like we did in a previous chapter. And so just use your calculator, use that second sign, and then type in the number if it is not a value that is on your unit circle. So if we want to evaluate the following expressions. So what this is saying is that this is an angle. So we want to find tangent of theta where cosine of theta is equal to 3 over 4. So this is similar to what we've done before. It just is in a different form because it's now using arc cosine or cosine inverse instead of saying this is what it is. So we want to draw a circle, or sorry, draw a triangle. And so if we draw a triangle, because it's positive, we know it's going to be in quadrant 1 because all positive inverse functions are in quadrant 1. And so cosine being 3/4 means that our x value is 3 and our hypotenuse is 4, because again, this is x over r. And so then we do the Pythagorean theorem to find our y. So 3 squared plus y squared equals 4 squared. So this is going to be y squared equals 16 minus 9, which is 7. So then y would be positive or negative square root of 7. Because we are in quadrant 1, it's going to be a positive square root of 7. And then tangent is y over x. So then tangent of arc cosine 3/4. So we still use the same triangle, and so it's going to be the square root of 7/3. Similarly, for this next one, and again, I always like writing it that this is theta. So we want to know what secant of theta is. Remembering that secant is then going to be r over x. And then this tells us that sine of theta is equal to negative 3/5. So because sine is negative, again, going back up here, sine inverse is in quadrants 1 and 4. So when we go down here for this problem, we want to draw our triangle in quadrant 4. So then this is y over r. So our y value is negative 3. R is always positive. And then we see that this is going to be a 3, 4, 5 triangle. Because we are in quadrant 4, we know that that means that our x value is positive. And so then secant is going to be 5/4. So then again, just to rewrite this using these terms, so secant of sine inverse of negative 3/5 is going to be 4/5. Okay, so our next one is a little bit more complicated, as if those weren't complicated enough for you guys. So tangent inverse is theta. So we want to find, this is saying that tangent of theta is 12/5. We want to find what sine of 2 theta is. So we will be drawing a triangle for tangent of theta. So let's go ahead and do that. And so again, it's positive, so we know it's in quadrant 1. Tangent is y over x. So that means that our y value is 12, our x value is 5. We can do the Pythagorean theorem, but this is a Pythagorean triple, so I know that my hypotenuse or my r value is going to be 13. So this is our triangle for theta, but we want sine of 2 theta. And so this is where we use our formula sheet. We're going to be using our double angle formula for sine. And so this shows me that sine of 2 theta is equal to 2 sine theta cosine theta. And so again, this is using the formula sheet. And so again, we're still going to be using this triangle that we drew for theta from tangent of theta equals 12 over 5. So then sine of 2 theta is going to be 2. Sine of theta is y over r, so 12 over 13. Cosine of theta is x over r, so 5 over 13. And so then we simplify this. And so 2 times 12 times 5 would give me 120. And 13 times 13 is 169. So this is our answer. And so again, just to sort of write it out a little bit more formally for you guys to see exactly what we did. So sine of 2 tangent inverse of 12 over 5 is equal to 120 over 169. And so again, anytime that we are taking tangent inverse, sine inverse, cosine inverse, that is an angle. So that lets us write that tangent inverse of 12 over 5 is theta, so which means that tangent of theta is 12 over 5. And so then if we replace tangent inverse with theta, that's where we get the sine. So this is theta. And so that's where we get sine of 2 theta. And then we use our formula sheet to get the 2 sine theta, cosine theta, and then we use our triangle to determine what that is. Okay, so these are the problems that we want you to try. So go ahead and write these down, and then we will see you in office hours this week. Have a good day.